we are going to do a little bit about molecular compounding today, and we're going to talk about the basics of molecular compound and then how to name them. So previously we did ionic bonding, and I actually want to draw it because some kids were having some struggles with ionic bonding. And again, I would encourage you guys to have a notebook, paper, pencil. So let me just stop sharing this and let's get to the whiteboard here. So in an ionic bond, remember we're going to have a positive and a negative attraction with each other. And that should make sense. Opposites attract, same repel. Hopefully you guys see my whiteboard. It's trying to, all kinds of old stuff here. I wish there was a way to clear it really quick without having to do all this. But anyways, in an ionic bonding, we're going to have a transfer of electrons. We're going to transfer electrons, and when we transfer electrons, we're going to create ions. Okay, positive ions are a loss of electrons, okay, and that's going to create what's called a cation. Okay, so and you probably don't have the app running. Okay. If we have a negative ion, that is going to be an adding of electrons, and that is called an anion. Okay, but then the positive and the negative, after they lose and add electrons, is what's going to bond together. They're going to be attracted to one another. So again, if I have oxygen, oxygen has 6 valence electrons. Okay. So 1, 2, 3, 4, 5, 6. Oxygen wants to gain 2 more. Or it could lose all 6. But gaining 2 is going to be a lot easier than losing 6. Okay? And so oxygen, when it gains those 2 electrons, oxygen is going to become a -2 charge on it. Okay? And so, for example, it could maybe get it from sodium. Sodium had 1 valence electron. It can either get rid of that valence electron, or it can add 7. Remember, octet rule, they want to have 8. Well, getting rid is going to be a heck of a lot easier than adding 7. Okay? And so after that happens, because again, remember, this is not the bond. Okay? Because they're gone. That's gone. That electron is gone. It is no longer there. That is not a bond. Okay, so that electron moves over here. Okay, it's done. So there is no bond. This is the bond between the positive and the negative. And so we would need another one to give its electron over here. And again, that negative is going to attract to the positive. And so we say that it has we use brackets for that, right? Show that it is an ion. Okay. And then we can actually crisscross the charges. Na2, oxygen 1, which we don't need to write the 1 on there because there's already 1 there. Okay. And that would be the bond that we have. We need 2 sodium to make 1 oxygen happy, 1 oxygen bond up with each other. Okay. All right. Again, if you guys are on your cell phone, you're probably not seeing that white screen, or if you guys are not using the app or the downloading the Teams to it, so you might want to check on that. Okay. All right. Of course, we're having some internet issues. So, all right. So today we're going to talk about molecular compound. Molecular compounds are different from ionic compound because they're actually going to share electrons. Okay. And so the bonding in a molecular compound, and you're going to get the word molecule from this, molecular, okay, is like a marriage. Okay. And so in a happy marriage, you're going to form a bond. Okay. It's more stable. Okay. In a difficult divorce, okay, you're going to break a bond, and that's going to be released. It's going to be less stable. And so in a molecule, they like to try to bond together to become more stable, and they're going to tug of war for each other's stability in that situation. Okay. So again, there are two types of bonding that we can do, an ionic versus covalent. So an ionic, one is going to give electron, one is going to take electron, and then a positive, negative will attract. But what if they both want the electron? Well, they can share the electron, and they can. They can share the electron. It's not a big deal. Okay, that does happen. So if both atoms want the electrons, so you're talking about non-metal. Non-metal would want electrons. If both atoms want electrons, they can say, hey, listen, let's share this electron with each other, and then we will become octet, we will become satisfied. Nobody's gaining, nobody's losing. Okay? So some compounds are different from ionics. And again, mainly because the positive and negative doesn't make sense. So they're not positive and negative, but rather the sharing of electrons. And these are between two non-metals. And we call that a covalent bond. And these are going to make molecules. So a covalent bond are atoms that want to gain electrons. You're talking about elements in the 4th, 5th, 6th, and 7th group. Okay, they want 4 more, they want 3 more, they want 2 more, they want 1 more. Then the 4th, 5th, 6th, and 7th group. Okay. So molecular compounds, these in nature, lots of different forms for molecular compound. Even the noble gases, okay, they are what's called monatomic. Monatomic means that there's only one of those types of atoms. They exist as single atoms all by themselves. So noble gases do exist as just one atom all by itself, okay? But the other ones are going to be unstable. They want to join together and make what's called a molecule. So a molecule is a group of atoms joined together by a covalent bond. Okay, they are sharing the electron, and they create a molecule which is more than one atom. You could have more than one atom, but they're the same atom. For example, oxygen. The oxygen you're breathing is not oxygen. It's not O. It's O2. You're breathing in O2. Okay, that is a molecule of oxygen. You have 2 oxygens that are bonded together. They both want the electrons, so they're going to share them with each other in order to be stabilized. You have quite a few of them. You have hydrogen is diatomic with 2 atoms bonded together. Nitrogen is diatomic. Fluorine, chlorine, bromine, iodide. A lot of those nonmetal gases are diatomic. They'll bond together to form a molecular compound. Water is a molecular compound. Hydrogen and oxygen are going to share the electron. They're going to be bonded together, and you get a ratio of H2 and O for water. Carbon monoxide are going to share an electron. You give a carbon, and you have an oxygen that are bonded together. Okay, those are called molecular compounds. And you note that in the name, especially carbon monoxide, I actually changed some of the rules from later. Remember, in ionic, it's just first name, last name, ends in "ide." Well, in molecular compound, the names are going to change, and we start using some prefixes. Okay. So this table, this picture is really important, especially for today's activity. Because I did not give it to you on today's activity. I'm giving it to you right here, right now. When you name a covalent compound, you need to have prefixes in there. And the reason why we use prefixes is because you can have lots of covalent compounds. In ionic, there's only one compound you can make between oxygen and sodium. But between carbon and oxygen, there's lots of different things I can do with that. So we need to have prefixes to tell us how many carbon, how many oxygen, how many atoms are in a molecule. And so you guys are going to need this list right here of prefixes. And you already know some. Carbon dioxide. Well, carbon is just one carbon. Dioxide means that there's 2 oxygen. Carbon monoxide. Carbon 1. But then the monoxide, 1 oxygen. So again, you guys already know a lot of these, they are prefixes. But prefixes are only for covalence. So if you see a metal, if you see an ionic, we do not use prefixes. Okay? And so we're going to practice some today on here. So when you name molecular compounds, the one that has the least electronegativity, the one that does not, one that's closer to the metals in group 4 or 5, are the ones that are going to come first for the first name. Okay. The second one, we're going to change its last name to "ide," which we already did that for ionic. Okay. Then we have to figure out the quantity and figure out how many do we need. So for example, in this one here, we have 2 nitrogen, 4 oxygen. So nitrogen is in group 5, oxygen is in group 6. So we're going to start with nitrogen. So it's called nitrogen and oxygen, right? Step 2, I'm going to change the last name to "ide," nitrogen oxide. And step 3, I'm going to add prefixes. There are 2 nitrogen, so it can be di-nitrogen. And then there are 4 oxygens. Go back to 4 on here. Tetra. So tet oxide. Okay, we don't need to put the A in there. They'll give us a double vowel, so you can drop the A. Tetroxide. So have you ever had the video game Tetris? It's called Tetris because the Greek for 4 is tetra. And every shape in Tetris is a variation of a cube or a variation of a square. So that every shape is a variation of 4-sided objects. Okay. So again, be careful with the shapes, the names. It's not quad. Quad is Latin. Okay, it's not. There's really not very many other ones on there. Tri is obvious for triangle. Oct for an octopus, things like that. You got hexa for 6, which is normal. Not a lot of tricky ones on there. Just watch out for the 4. It is the Latin one on there. The prefix mono is only used for the second element, not the first. The reason why we do that is because, alphabetically speaking, if we put mono in front of all the compounds, you would have a bunch of them that started with mono. So we just do one atom. It's just the first name of that atom itself. Okay, we don't say monocarbon monoxide. We don't say monosulfur trioxide. If the first element only had one, just say the element's name. Okay, so we never start with mono, but mono can be the second name on it. All right, so when you're writing chemical formulas, it's super easy. Okay, you figure out the symbol for each, you figure out the name, and then you write down the formula. It's pretty simple, okay? Especially if you're given the name. So sulfur, well, I guess there's only one, because it's just sulfur. And trioxide, well, that's oxygen. Tri means 3, so 3 oxygen with the 3. Okay, so we're going to practice a lot of these here in a second. So let's pop up that worksheet. I'm actually going to do some with you today. Fair warning on today's assignment. If you look at the actual assignment itself, it said there are 3 ways to do this.
Can everyone hear him? I can't hear him.
Can you? Can you guys hear me? Okay. Everybody else? We're gonna try to do a bunch of practice problems together.
Maybe it's me. I didn't finish. I'm gonna leave and join back.
Well, they're all saying yes. So. All right. So Nick's coming back in. All right. So for today's activity, there are a couple ways you can do this, and you're gonna see this a lot coming up because we're gonna have to start doing some drawings. We're not drawing today, so today is gonna be real easy. You can do today on a computer. Some of you are really good at drawing. You guys are using some kind of Ludichart or something like that. You guys are using some kind of graphic tool. I really like it. So you guys should use that too if you want. I personally think that drawing on paper with pencil is just a lot faster. It's a lot easier. So as we start doing more chemistry for real, we are going to have to start drawing stuff out. We're going to have to start writing things. So today's assignment, if you look on Canvas, there's a couple of ways you can do this. Just answer it, submit it on a Google Doc, which is probably what you're going to do for today. You can print the Google Doc, answer all the questions on paper, take a picture of it, turn it back in. Or you can, in a notebook, just say number 1 with this, I'm going to answer it. Number 2 is this, number 3 is this. So if you don't have a printer, you can just write on a piece of paper, take a picture, and submit it like we normally do. Today, you're probably all going to be okay with number 1, just typing in the Google Doc and then submitting. However, we do need to start practicing subscripts, making the numbers smaller. Actually, I did give you prefixes. We need to start practicing the subscripts and making sure we're doing the subscripts correctly, because there is a difference in chemistry between a regular number, a superscript, and a subscript. So we do need to make sure we're doing that. And again, if you guys watch me right now, if I want to make this 5 a superscript, I just go to Format, Text, Superscript. If you look, there's a little shortcut. You do central plus period, and that will make it a superscript. If you want to do a subscript, which is what we're going to do today, we're going to do subscripting. Just go to Format, Text, Subscript, and write down our formula. All right, so I'm going to do the first couple with you. So let's go ahead and do them together. Go ahead and grab this worksheet. And again, many of you, or not many, but some of you have already done this. Just double check your work, okay, before you turn it in. All right, so in box number 1, we are going to name it. We're actually going to write out its name, okay? And over here on part B, we're going to write out its formula, okay? So, so the first one, again, there's only 1 carbon, but we're never going to start the name with monocarbon. So the first name is just carbon. And then there's 1 oxygen. So it's going to be monoxide. Okay, so again, it's not oxygenide, but there's 1, so it's monoxide. Okay, so you do need a prefix for the second name. So I just gave you the answer to that. Carbon monoxide. Again, you had to know that one. You've heard that before. You've probably been hearing about it a lot in the news in Texas with all the people running generators and getting carbon monoxide poisoning right now. That's a sad day going on in Texas, I know. All right, so the second one, 1 nitrogen, but again, we never start the first name with mono, so it's just nitrogen all by itself. So nitrogen. And then there's a 2 by that oxygen, so it's dioxide. Not monoxide, it's dioxide. So that one is just going to be nitrogen dioxide. All right, let's go over here to 18 and 19. Okay, these are pretty simple because the answer is in the name here. Okay, so it's carbon tetrafluoride. So carbon, obviously you only had 1 because there's no other prefix. So it's just 1 carbon. And then tetra means 4. And then fluoride is fluorine, so that's F. You're probably going to need your periodic table. So F with a subscript 4. And again, please practice using a subscript, especially in chemistry. So again, if you guys want to do it on paper, do it on paper if you don't like doing the whole shortcut stuff. So again, 1 carbon, fluorine 4 with a little 4 at the bottom. Okay. Let's go to one that's a little bit more interesting here. A lot of them just start with 1 on there. Let's do number 20 real quick. So the shortcut on your keyboard is Control plus period, or no, that's a superscript. It's Control plus comma. That's a shortcut for how to do a subscript. So highlight it, Control plus comma. But it's right there too. Just highlight the 4, come to subscript, click on it. So again, if I was going to write that out, I would do CF4, right? I would highlight the 4, come up to text, click on subscript, and then add my formula, CF4. Or you can not do that. You CF4, highlight it, Control plus control, and the comma. Control comma. Let's look at number 20. Number 20 is a little bit more interesting, but again, these are all pretty simple. So dinitrogen, so it's N2, and then tetrasulfide S4. And again, I would highlight the 4, subscript it, I would highlight the 2, subscript it, and there's my formula there. All right, now, hydrogen, down here. Remember, these are molecular compounds. It's not just hydrogen by itself. Hydrogen is not just H. It's H2. These are diatomic compounds, okay? So they are 2 atoms bonded together. And you get that. So anytime you just see hydrogen or oxygen or fluorine or whatever, okay, it is that atom bonded twice with itself, okay? And that's what it means to be a compound. 2 atoms bonded together, okay? Or 2 or more, okay? So it's not just an element, it's a compound itself. Okay, there are some other ones here. These are everyday names. They're pretty simple, little extra credit. Figure out the formulas. You probably know one of them already, I hope. I hope you know water already. But again, a little extra credit to go find the common name with a couple of formulas. All right, I'm going to put you guys into breakout groups. And I'd like for you guys to work on this today. And that's it for me today. You guys are just going to work together and help each other out with this handout. If you have already done the work, help the other classmates. Double check your work. You know, help the other kids make sure they understand how to do the formulas and how to do the names. And again, it's going to just be practice here. But again, we never start the name with mono. Okay, if there's only one, it's just that name, carbon, nitrogen, sulfur. But if there are 3 sulfurs, then it's trisulfur. We do start the name with other stuff. Okay. Again, there are examples, there are rules are up here, so feel free to use those. Okay, do not use mono to indicate only the second element gets mono. All right, I'm gonna put you guys in a breakout group. I would actually like for you guys to talk about stuff and help each other. Okay, so I'm gonna put you guys into four groups. I'm gonna stop the recording because it doesn't do breakout groups. If you guys have questions, make sure you guys ask me. You know, put them in the chat box. I'll come in and say hi to you guys. If you're in the classroom right now, obviously I'm here to help you guys. Again, this should be done today. It's not that hard. It should be done today, and you'll be able to turn it in and get an A+ on it. All right, here you guys go. Off to the breakout room.
Whenever it says mono in front of it, do we put the 1?
Yeah. Yep. So mono